Hello everyone, how are you? This video is about straight line graphs and their gradients. In the last video, we looked at the general idea of a straight line and how to draw a straight line once you have the equation. In this video, we're going to look at the slope of a straight line, which is also called a gradient. So here is our original example, y equals 2x plus 1. And if you remember back to the last video and our basic form of a straight line, y equals mx plus c, we said that the gradient is equal to the variable m. And that means in this equation, the gradient is going to be 2. But as we also said, the gradient of a line is the slope, which is how flat or not flat the line is. This is not shown as an angle though. We define the gradient by dividing the amount the graph goes up by how much it goes along. And this is commonly written as m equals rise over run. Let's have a look at that on this graph. If we start at the lower corner of the triangle at x equals minus 2, then we can move along 3 places to x equals 1, and then we have to go up 6 places all the way from x equals minus 3 to x equals plus 3 before we meet the line again. So if we go along 3, then we have to go up 6. So the rise is 6, the run is 3, and m is 6 divided by 3, which is 2. We didn't have to choose this triangle. We could choose any triangle that works on this line. The simplest one would be to go along 1 and up 2, and then rise over run would be 2 divided by 1, which is still 2. Here we plot the same graph again, but this time we are doing it on a different scale. And what does scale do to the gradient? Well, absolutely nothing mathematically. The scale of the y-axis does not change the line, and so it does not change the gradient. In this graph, the run is on exactly the same scale, but the rise has changed scale. So when we draw our triangle, the run is still 3, the rise is still 6, but now because of the scale, that rise seems to be smaller, but this is just an illusion of scale. This is why the gradient is a number calculated from the graph and from the equation and not an angle in degrees, because the scale that we draw our graph on can change what that angle is in real world terms. But mathematically, the gradient of this graph is still 2. Here is our second example equation. We know that the gradient m is equal to 3. Can you identify a triangle that demonstrates this by looking at the graph? There are many triangles you could choose, but here is one. If we go from x equals minus 3 to x equals 2, that will be a run of 5, and then we have to go up from minus 13 to plus 2, which is a rise of 15. So rise over run is 15 divided by 5, which is 3. In fact, there are infinite triangles that you could pick anywhere along this line, and they will all give you exactly the same value for the gradient as long as you use a right-angled triangle. But we'll come back to that. Gradients can also be negative. Take a look at this equation, y equals minus 2x plus 1. This is very similar to our first example, but m is now negative 2 instead of positive 2. What do you think is the effect we will see on the graph? Have a think about that, but if you need a hint, think about it this way. If m is a negative number, that means that the rise becomes negative because as you follow the run, you are going to go down, not up. Let's look at that line now. Here we are. And you can see that if you make a gradient negative, then you mirror the graph in the y-axis because anything on the negative x is going to give you the same result as you would have found on the positive x if m were a positive number. The y-intercept is still 1 because c is still plus 1. And we can still calculate m in the same way as rise over run. But as I said, this time when we go 3 along, we have to go 6 down. And so m is minus 6 divided by 3, and so the gradient is minus 2. So we'll leave gradients there for this video. I hope you now understand what gradients are and how to calculate them a little better. I hope you understand what happens when a gradient is negative and also why we represent the gradient as just a number in the equation. Even though it represents something real like a slope, depending on the scale, the actual angle of that slope can be different. So we represent the gradient as just a number that is calculated from the points on our graph. Thank you for watching.